This is the tutorial for working with sets, Chapter 3, Section 5, and so what they're introducing to you is what we call set builder notation. It's just a way of conveying the answer, so I'll show you that once we come up with the answer. So you're going to solve these the same way you'd solve the problems in Chapter 3, Section 4. You're just going to use opposite operations to undo the equation. Use the distributive property here first. So negative 6x minus 14 is greater than negative 14. So when I go ahead and add 14 to all sides, I end up canceling out the 14 on both sides, the inequality sign. So I'm left with negative 6x is greater than 0. If I divide by negative 6, well, 6 goes into 0 times. So x is not greater, but less than 0. So the reason why it's less is because I divided by the negative. So whenever you divide by a negative, that's going to end up switching that inequality sign to what I have down here. So if I was to graph this, 0 would be in the center, 1 would be to the right, 2 would be to, actually negative 1 would be to the left. And it would be an open circle in the 0. X is less means left, so that's the way we'd go. But I wanted us to use the set builder notation. So what we're going to do is we're going to start off with these braces. I'm going to try drawing those once more. So the brace signifies that we're dealing with a solution. A solution set is what that represents in math. So inside the brace tells us what the solution is. So we write it this way, all values of x such that. So these symbols here, the x and the line represent all, or it's read as all values of x such that, and then we write down the values that x is. So for instance here I would say such that x is less than 0. And then I would close the brace, and that represents the solution set. So again, the solution set is just inside some braces to tell us that we're dealing with a solution. And the first x just tells us what variable we're dealing with, and the line here just represents the word such that, and then x is, in this case, less than 0. So we'll see that with these other problems, except these are a little different, so let's take a look at it. Negative 6x minus 14 is greater than negative 14 minus 6x. So when we go ahead and solve this, I end up having to bring the x's to one side, but as I do that, I end up with something a little different here. I end up with the x's canceling out. And so I end up with this, an inequality that is not true. So it says negative 14 is greater than negative 14. That's false. So if it's false, we say there is no solution. So there are some symbols here, and we're also going to show you in the roster form how to do that. And so no solution just means a 0 slash through it, or we could say the empty set. So the empty set means the same thing. It means there is no possible number that could go inside a set of braces. There's no solution. So there's the empty set. So let's take a look at the next one. Here we have to distribute, and I have negative 12x minus 24. Bring down the plus 1, and then I'm going to use it. I need to get an inequality sign in here. So let's go with a greater than. And let's see, yeah, greater than, that sounds good. And let's do greater than or equal to. How about that? So is greater than or equal to negative 23 minus 12x. So when I go ahead and do some more work, I can go ahead and collect these two terms. So I have negative 12x minus 23 is greater than or equal to negative 23 minus 12x. So from this point, I'll just go ahead and add the 12x to all sides. And I've got negative 23 is greater than or equal to negative 23. Well, this time I have the equal sign here. Remember, that means greater than or equal to. So because it's equal to right here, that tells me that this is a true statement. And so that means we can have an infinite number of solutions. The way they register that inside the set builder notation is they say, Here's our solution set, all values of x such that x is a real number. Real number. And so that tells us that it could be any real number. As long as it is a real number, we've got a solution according to the set builder notation. So there it is. So those are the types of problems you're going to end up seeing. So you may not see a lot of empty sets or x is a real number, but you will see other answers where you do get a solution like this. And so we're just using the set builder notation, or practicing using that. And that's what you'll see in tonight's homework. Good luck.